Welcome to this video on expressions, exponents. This is a fairly big topic, so this will definitely go into a second part. We'll just continue whenever we run out of time here. Okay, so exponents. Let's just talk about what an exponent is. First of all, this is something written in this form, 2, say to the third, with a smaller number that's written above and to the right of the number. The big number on the bottom is called the base, and the smaller number up to the right is called the exponent. And what that means is you take the base, in this case 2, and you multiply it by itself the exponent number of times. This would be 2 multiplied by itself 3 times. So 3 2's multiplied together, okay, which would be an 8, right? So that's the definition of, the basic definition of what an exponent is. Of course, it can get more complicated if we have other situations. We're going to talk about, for example, what a negative exponent is here, and rules for combining expressions to exponents. And then when we get to the radicals, video coming up next, we'll talk about fractional exponents and related topics. Okay, so let's talk about some properties. I find that it's easiest to learn the properties if you look at them with numbers, but I'll show you also the formula versions of these properties. So the first thing is, let's say we have the same base, 2, and we have 2 to the third, and then that's multiplied by 2 to the second. What do we do in that case to combine that into a single expression? Well, the 2 to the third is 3 2's multiplied together, and the 2 to the second is 2 2's multiplied together. So really, since you're multiplying, really we have a total of 5 2's multiplied together, and that's why 2 to the third times 2 squared is the same as 2 to the 3 plus 2, or 2 to the fifth, right? We would just add the exponents, because we have 3 from the first one, we have 2 from the second one, so we have to add them together, and we have a total of 5. Right? So when bases, like bases, are raised to exponents, you can combine them by adding the exponents. This is what the rule looks like in symbolic form. A to the m times a to the n, the same base a, would be that base a raised to the m plus n. Alright, so that one's not too bad. It works also for dividing. If you think about what that looks like, this 2 cubed is 3 2's on the top that are multiplied, and the ones on the bottom, there's 2 of them multiplied together, right? So in a way, right, the 2 on the bottom are canceling off 2 on the top. So instead of adding, the ones on the bottom should be subtracting from the total number of 2's, right? This 2 over 2 is a fraction that equals 1, so it can be removed. And this 2 over 2 is a fraction. And so I'm left with just 2, or 2 to the first, right? And so that's why 2 to the third divided by 2 to the second is the same as 2 to the 3 minus 2, because anything on the bottom of the fraction here subtracts from the number on the top. So that would be equal to 2 to the first. And here is that rule in symbolic form. A to the m over a to the n is a to the m minus n. Okay, so something on the bottom effectively subtracts from the number on the top. Okay, in fact, if you look at that more closely, 2 to the third over 2 to the second, right, is the same as 2 to the third minus 2, but because we know that we can express 2 to the third minus 2 as a 2 to the third, right, times a 2 to the negative second, it does mean that anything on the bottom of the fraction that's positive, like 2 to the second, can be effectively moved to the top of the fraction, and the exponent can be made negative. And it works the other way around too. If you have 1 over, looking at this one now, if you have 1 over 2 to the negative first, you can just move that 2 to the negative first to the other side of the fraction and change that exponent from a negative to positive. So this is what the rules look like symbolically. 1 over a to the negative n becomes a to the n over 1, or a to the negative n over 1 becomes 1 over a to the n. But this is what it means in terms of words. It means that if you have a negative exponent, you can move that to the other side of the fraction and change it to a positive exponent. That's the way I remember that. Okay, so that's an important idea. Okay, let's say that I want to simplify this, 5 cubed over 5 squared. Well, there's really 2 ways of going about simplifying, right? We can use properties, or we can kind of use factoring and then canceling techniques, right? So let me do it both ways so you can kind of see the difference here. Let's say that I wanted to use the properties. Well, the properties tell me that this is equivalent to 1 5 raised to the 3 minus 2. And so that would be equal to 5 to the 1, which is 5. Right? That's the way I would do this using properties. If I wanted to do it using factoring, I might do it this way. I might say the top is 5 squared times 5, and then the bottom is 5 squared times 1, and then use the fact that this right here is a 1, so it cancels. and gives me a 5. So both of those ways are perfectly good ways to think about dealing with exponents, and I would encourage you to practice some either way, because in some cases one is easier than the other. But you can use properties directly, or you can think about it as expanding it out and then canceling, as long as you cancel appropriately. Okay, here's maybe a more complicated situation. We have 5 cubed times 5 to the minus 4th divided by 5 squared times 5 to the negative 7. Okay, let's do it both ways. Let's use properties. Maybe what we do on the numerator, first we use the fact that if I combine across the top, right, this is the same as 5 times 3 plus a negative 4. And on the bottom I have 5 times 2 plus a negative 7, which is the same as 5 to the negative 1, and then 5 to the divided by 5 to the 2 minus 7, which would be negative 5. And then if I use properties, I know that that's 5, and it's going to be negative 1, and then minus whatever's on the bottom, which is negative. So that's going to become a plus. So that's going to end up being negative 1 plus 5, which would be plus 4. Right, so 5 to the 4th. This would be 5 to the 4th, which of course I could multiply out, but for this purpose I'm going to leave it in that form, 5 to the 4th. Okay, so let's do the same thing but using the factoring method here. Well, let's do this. What I would do if I'm going to do factoring is I'd go ahead and get rid of negative exponents by using the property that they can move to the other side to become positive. So some people prefer this. What I can do is let me rewrite it, and if something's already a positive, I'm going to leave that on that side. But if I have something to a negative exponent, I'm going to move it to the other side so that it can become positive. Like this 5 to the negative 4 on the top would become 5 to the positive 4 on the bottom. And the 5 to the negative 7 would become 5 to the positive 7, but on the top of the fraction. And then I can combine and say that means I have 10 5s multiplied on the top, and I have, let's see, 6 5s on the bottom. And then I can factor this by saying 5 to the 10th is 5 to the 6th times 5 to the 4th, 5 to the 6th times 1, and get 5 to the 4th that way. Right, so both are perfectly good ways to do it. It depends on whether you like to be really careful with negatives of negatives, or whether you want to get rid of negatives right away and then use canceling techniques. Okay? All right, let's take a look at some other ones. At any point here, you can stop the video, give this a try, and then unpause and see if you're getting it correct. This one's more complicated. It involves 5s, 3s, A's, and B's, and so you have to do these operations on each piece separately. Okay, if we wanted to use properties, right, the way we would do that is maybe we deal with the 5s, so that would be 5 times 2 minus 5. And then we would have a 3, negative 3 minus a negative 6. And then we have an A, and that's an A1, so that'd be 1 minus a negative 2. And then we have B, and that's going to be 5 minus 2. Okay, so if we're careful about this, we have 5 to the negative 3. Then we have 3 to the, that's going to be 6 minus 3 is 3. And then we have A, that's going to be 2 plus 1 is 3. And then this is going to be B3 also. And so maybe what I would do is get rid of the negative exponent here by just moving that 1 to the other side of a fraction. And that would be, what is that? That'd be 3 cubed, A, B cubed over 5 cubed. And, you know, we should probably go ahead and fully simplify. 3 cubed is, 3 times 3 is 9 times 3 is 27. So that would be 27a cubed b cubed over, and 5 times itself 3 times is 125. So that's what that simplifies to if I use properties. Okay, let's use the factoring and canceling out method here, also just for comparison. And then for some of the other ones, we'll just pick one or the other so we don't use up too much time. If I did factoring here, I might be tempted to say this 5 here, but this is 5 cubed times 5 squared, so that those are going to cancel and leave me with 5 to the 3rd on the bottom. And then here I'm going to move the 3 to the negative 3. I'm going to move it to the other side and make it positive 3. And this will be, in fact, actually that's what probably should do as a first round. First thing we should do, I guess, is to just get rid of all negative exponents. Let's just write it over again. And then I'm going to move anything that's a negative exponent to the other side and make it a positive exponent, right? And then this is an A here, but I've also got an A to the negative, or A to the 2, because that negative 2 moves up, right? And then I've got a B to the 5th on the top and a B squared on the bottom. So what do I have here? I have 5 squared, 3 to the 6th, A cubed, B to the 5th, over 5 cubed, 3 cubed, b squared. Okay, now we can kind of try to factor and cancel. So I've got more 5's on the bottom here. So we have 5 squared on the top, but I have 5 times 5 squared on the bottom, leaving 1 5. Is that right? Wait a second. I think I made a mistake here. Let me correct that. I copied something incorrect up here. This should be 5 cubed, and then 3 cubed, and then b squared. So picking it up from there, yeah, I did it again. It's 5 to the 5th. 5 to the 5th. I keep writing that incorrectly. Let's see, and that's b squared. Okay, continuing, we have now, let me combine these to make an a cubed. We have 5 squared on the top, and that means I have 5 cubed times 5 squared on the bottom. I have 3 to the 6 on the top, which I'm going to split as 3 cubed times another 3 cubed. 3 times 3 is 6, so that I get to cancel that out. Right, I have an a cubed on the top and nothing on the bottom to cancel it with. And the b to the 5 I can split into b squared and b cubed, so that the b squareds cancel. So what am I left with? On the top I have the 3 cubed and the a cubed. Right, and on the bottom I have the, and I have the b cubed. And on the bottom I have 5 cubed, and that's it. And so I'm left with the same thing as before, 27 a cubed b cubed on the top, and 5 cubed, which is 125 on the bottom. Okay. You know, it's looking almost like the properties might be a little less work, depending on how you like to think about it. Okay, let's continue with some additional properties here. This is definitely going to go into a second video, but that's fine. It's better not to rush this, because these are important things. What does it mean if I raise a base to 0? Well, let me express it this way. 2 to the 0, I hope you agree, would be equal to 2 to the 3 minus 3, or 2 to the 5 minus 5, because 3 minus 3 is 0. Well, what does that mean? I could write that as 2 to the 3rd times 2 to the negative 3rd, which is the same as 2 to the 3rd divided by 2 to the 3rd, if I move this 2 to the negative 3rd to the bottom. And what is 2 to the 3rd divided by 2 to the 3rd? Well, that's equal to 1. And so what that means is 2 to the 0 is equal to 1. Right? In fact, anything to the 0 is equal to 1, because you could do this procedure on it. Right? And the only caveat is that the base cannot be equal to 0, because 0 to the 0 would be undefined. And the reason for that is if you tried to do all this stuff with it, you'd end up with 0 to the 0, or you'd have something like 0 cubed over 0 cubed, and you can't have dividing by 0 here, right? So that would be undefined. So as long as the base isn't 0, anything raised to the 1 power is always equal to 1. Okay, let's say a couple other things here. Just to keep in mind, right, 2 to the 3rd times 2 to the 4th, we learned was we add the bases in that case, and we get 2 to the 7th. What happens if I have 2 cubed and then I raise that to the 4th power? Well, each 2 cubed here is 3 2's multiplied, but if I multiply that by itself 4 times, then that means I have to have that 3 4 times. So you would have to take 3 times 4. So that's why this would be raised to the 3 times 4, or 2 to the 12th, right? If you multiply bases together, then you add the exponents. If you take an exponent and raise that to an exponent, then you multiply. Okay? So those are the two cases for contrast there. Okay, a couple other things to be aware of as far as properties before we get into some more complicated examples in the second part here. If you have something like 3b raised to the 2nd power, I know a lot of people are tempted to think of that as distribute the exponent to the 3 and the b. But I want you to be cautious about that idea, because what this really means is 3b times itself. And it does turn out to be 3 squared times 2 b's multiplied together, right? But if you had something like 3 plus b squared, right, that's 3 plus b times another copy of itself, right? And so that would end up being, you'd have to do the distribution procedure. Everything in here times 3, 9 plus 3b, and then everything in here times that b, plus another 3b plus b squared. And so it would be 9 plus 6b plus b squared. It's not the same as just 3 squared plus b squared. In fact, let me write it here in red. People will be tempted to think that this is equal to 3 squared plus b squared, but that is not true. Don't do that. Don't distribute the square. Instead, think of it as that quantity multiplying itself twice. Okay. Let's see. Same thing in the division case, right? 3, if it's like this, right, you do have, that really does mean a 3 over b multiplied by another 3 over b, so that is the same as 3 squared over b squared. So you can think of it as every